Hey, this is Nate Webb. Have you ever walked into a lighting application where you're going to do some service or work or with a client and they ask you about something you've never heard of before? Digital LED lighting. Maybe somebody uses the word like SPI or TTL or programmable or pixels or motion graphics LEDs. Have you ever heard any of those kinds of things? Well, here I'm to help you guys out on a series of videos. We're going to dispel what digital lighting systems are all about. Okay, so we're going to get started. There's a number of things we could talk about in the audiovisual industry, which we do a lot of work in. We set up LED walls. No doubt that anybody who's been out in the world, you have seen LED signage walls. These are the digital LED billboards you see along the highways, the little running pixel things you see around different stores, walking into 7-Eleven. You're seeing digital signage, all using LEDs, and they've been around for a really long time. In fact, a lot of LED matrix types of displays were being used clear back in the 80s. So people would put together little dip type LEDs and they would make an entire matrix out of it, and you could present motion graphics, moving words, those kinds of things. Newer versions now have red, green, and blue colors and other kinds of full colors, and now they've moved into smaller dip type chips, and you get into resolutions where you can't tell if it's just a video wall, whether it's projection or LEDs. A lot of times, the way to tell if it's projection versus an LED is that the projection is going to not be quite as contrast black or dark images and bright colors, whereas the LED walls will. And I predict probably in the next few years we're going to start seeing LED displays where they're actually LED matrix types of displays being shipped to homes. I'm sure you can get one for your house if you're willing to spend $25,000-$30,000 on it. But for the rest of us, we're gonna have to wait a few years. Excuse me. In this particular video, I'm going to talk about another type of, basically, it's LED digital pixel lighting, very similar to what we see in these Matrix videos and these Matrix video displays, but it's being used into all kinds of different products. So we have products that are like this for the sign lighting industry. So these are used a lot in backlighting signs and those kinds of things. This one is an RGB smart intelligent pixel. We'll see Christmas types of projects. In fact, we build a lot of trees or Christmas trees and pixel trees. Downtown Denver has a massive tree called the Mile High Tree, all built out of these types of things. We've built a number of those types of trees out of these types of products. These are SPI type product. You'll see a digital LED tape. So there's a lot of tape light. Buy this stuff on Amazon. Comes in different kinds of resolutions. If you look really close to this one, this is an LED every inch, so it's really high resolution types of stuff. Whereas pixel pitch between these, this is how we talk about how many millimeters or inches are away from each pixel. So in this case, this is a pixel pitch of nearly 4 inches. I don't remember exactly the millimeter length on this. And then the pixel pitch on this LED strip is 1 inch. So obviously we have more pixels per linear foot. Some of the big displays we were just talking about, they can be like 1.2 millimeters. I think I've even seen a 1 millimeter pixel pitch LED display. In fact, I was just running a show down in Florida in Orlando at the Gaylord Hotel, and we put up a display that has, I think it was 2.4 millimeter pixel pitch. It looked like a video display from across the room. In fact, you didn't see the pixels until you walked up into it. So these pixels are controlled by what's called a processor. Now, a processor does a couple of different things. In the video wall industry, processors will take the video from an HDMI off your laptop or a video media player of some type, and they'll convert and process that video information into the LED information and send it on to the LED tiles. In SPI and Pixels, we actually use these types of controllers. So looking back over here at my bench camera's tracking me. Anyway, so we use these types of controllers. This is an SPI controller. This is basically a Chinesium generic controller called the BC216. The reason they call it a BC216 is if you look at this side here, there are 16 SPI outputs. And then on this side, they have 2 DMX outputs on actual theatrical XLRs. But you can also hardwire them into these Phoenix style connectors here. This is where our power injection port goes in, and the all-knowing, all-everything SPI or Ethernet port. So this is where it becomes digital, is through that Ethernet port. Through the Ethernet port, we're sending a protocol that is a Ethernet or DMX over Ethernet called ArtNet. And this particular box receives exclusively just ArtNet, and it processes that ArtNet lighting control information to the SPI pixels. Here's an interesting thing, and I'll go brief, is that DMX through a single channel XLR is called a universe, and there's 512 channels of DMX in each universe. One cable can carry one universe of DMX. Of those 512 channels, each channel has a resolution from 0 to 255. So as you raise your fader up and down on your lighting board or in your control software or whatever, it adjusts the variability to 255 increments. And that's called 8-bit on that. If you went to a 16-bit pixel, and there are fixtures that are 16-bit pixels and other types, it would actually use 2 faders, right? So you double the bit ratio. So it gives you a finer resolution of dimming control, things like that. Each pixel now, when we talk about the pixels, most every pixel, whether it's a module like this or others, they're going to be red, green, and blue. So there's going to be a red LED inside of each one of these little chips. There's going to be a green LED and a blue LED. That's what creates the white light. And it's kind of more of a purplish white light when you see it. From distance and watching it on a TV, it can be bright white, like a normal bright white. And displays are able to compensate for that. And that's where you come up with the display settings, things like that. That actually still applies in SPI digital DMX lighting as well. So this intelligent, smart digital lighting has the processors, and you're sending the information from a couple of different ways. One of the ways can be a computer software. So like for instance, on board here, there are some information. This already has like a web server software that lives on it. So when you dial into this on the network, you can actually see this, configure it from the internet or from your laptop on a network. And you can actually do some testing and function controls and various things like that. But where this really comes to life is when you actually process information from a lighting controller or even a video controller, and I'll talk about that later, to give the information to this processor for it to process that information and send it off to each one of these SPI locations. Here's the thing about SPI too. SPI is a serial protocol interface that can have on each one of these outputs. Each one of these outputs can have up to 1,024 pixels. Yes. And so I can run up to 4 universes of DMX on a string of pixels without them having problems. And in fact, I think even some of these little small units can go as high as 2,048 pixels on each one of their outputs as well. So it depends on the capability of the controller, depends on the processor, controller processor, and it depends on some of the functionality of the pixels, and then it really is going to come down to how you inject it. So I have a little small controller. I was trying to find it here. All right, well, I'll just use this one here. So this guy right here, he's a little tiny microcontroller. He can control 1,000 pixels from this one little tiny, what is that? 1.5 inches, 2 inches wide by 3/8 of an inch thick. And look how thin it is. So all the little tiny electronics on here, they've pre-programmed this to run about 200 different programs. You access it through these 3 little tiny buttons here. You can't program new stuff, so you just get what they give you. Programmed in the factory somewhere in China. And then you can run downstream to these kinds of Christmas type pixels or even that pixel strip up to 2,048 pixels on that one little controller. It's pretty great. Let me show you something here too. Actually, let me get into this. So think about this. Once you send the SPI protocol from your pixel controller interface, converter, whatever you want to call this, it only goes so far. So from this point of contact out to a certain point, maybe 3, 4, 5 meters, that's about 16 feet or so, you might get the pixel out to that far. Other systems will allow you to do transmission, and there's lots of ways to do that. There are companies that have come up with other controllers, and let me show you guys this one. This is one of the ones kind of my go-to. Again, I'm not being sponsored by this. I wish I was, and maybe I eventually will be. But for right now, I'll show you this great technology. This is stuff that a lot of people don't know about. So this right here is called the Digidot C4, and it's the extended version. So this little box right here through this little Phoenix output on this one side, receives it receives power through this little port here, but it also can receive power through the port here and send up to 4 outputs of SPI or a combination of SPI and DMX from this one controller. So it's very similar to this. It's got a little bit limited. It doesn't have quite 16 of them. It's a little more expensive than that guy. But onboard software here is you can actually program and build and control your entire light show on this box without other software. You can also, behind this little guy, or kind of just right in here, you'll see it's got a micro SD card on it, so you could store all of your stuff. It also comes with an analog trigger control whip that can go in here, so it plugs into a little headphone style jack and control inputs and outputs. So if you had like door opens and other kinds of triggers, that would trigger some of the programming, and you can program a lot of that inside of this one box. This can stand alone as an automated automation box as well. And then on the very end here, we also have the I guess that's where the power was, and the network. The cool part about this is, like, for instance, on the other one, it only had one network, so I'd have to have a network switch upstream to distribute the network to it. These guys, I can mount them in racks, go in one port, and just loop to the next guy, the next guy, the next guy. So it automatically has a looping network switch inside of it. That's huge for big installations because it eliminates the need for a lot more wiring, and it eliminates the need for like a central star hub for your networking controls as well. So that's pretty important. So there's some pretty cool aspects to that, and that's the Digidot C4 Extended. There's a couple other companies, we'll talk about them as well. New companies that are coming out. They're actually putting some good competition to these guys. I like this stuff. Some of their stuff can get pretty expensive, especially when you get up to the bigger extended things that they do. But Digidot and a couple other companies have only really come up with the first place to do extensions. And SPI extending is the biggest issue. It's the biggest limitation of SPI systems entirely, is that, going 16 feet from your controller to your light string doesn't necessarily make sense for when you're going to put an SPI protocol system out, like say in your landscape or your yard or on the top of some building. I don't want to go out and hang off the side of a parapet looking over, to the abyss and having to be like tweaking on little tiny microcontrollers. I just don't want to do it. So it becomes a problem when you think about extending or sending SPI pixels a long ways. Guys that don't know how to use the pixels or don't know about these kinds of technologies out there, they might steer away from what would be great. Maybe the client wants to do some kind of motion pixel thing on the top of their building, and you're like, well, I don't even know that there's anything that works like that. So that's where these things come in. So here's this guy. This is the main controller, and here's a box that they have. This is called the extension kit, or what is it called? PixelNet transceiver kit, right? PixelNet transceiver kit. I remove the Phoenix connector, so I pull that out of there, put that aside, and on this device is like a little sidecar. It's got the female side of the Phoenix connection plugs right into this guy. Oh, couples together. I mean, it's like it was made for it, right? So this thing can receive the power now from the power port on this side. It can also receive the power port on the inside, which would in addition also power the C4, so you can wire it directly through this guy. And then if you notice on this side, it looks like a little baby network switch. It's got 4 RJ45s coming out of it. That's interesting. Well, these are not network RJ45s, so you don't want to plug your network switch into this. But these are for extension. And this is where the magic comes in. Because what's actually happening here is we are extending... Did I grab the right box? We are extending our SPI. And we're extending it up to 330 feet. That is significant. 100 meters, 330 feet. So to do that, this little extender transceiver kit is converting the SPI protocol signals inside the electronics of this portion, putting it onto an RJ45 type of wire, which is a network wire. I mean, we're talking dirt cheap connections. Pretty much anybody that's been in the electrical or low volt data industry in any kind of time, you'll notice that pretty much everything is being networkized, right? It's the Internet of Things. So everybody should know how to do RJ45 connections. I do a training course on that specifically, so if you don't know what the proper pinouts and how to terminate these kinds of cables are, how to choose the right wire and how to do that, there's outside plant wire for this. There's grounded and shielded wire for this too, so there's all kinds of really cool things, but everybody should know how to do this. If you don't, let me know. I'd be more than happy to come out and train your team on how to do it. But from that transceiver, that transmitter unit that's coupled into the back of the C4, they now have these little converters. And so this little kit comes with 4 little converters. Now this is a tiny little PCB, right? And if you notice on this one side here, there's a network port right there. Oh gosh. Okay, so my camera doesn't like it, but yeah, there's a network port right there. So my little network RJ45 connector plugs right in. Click right into there. And then on this side, you can inject power in through there, or you can wire power straight onto this, and then you can wire directly to your output of your strip. So you can either go right straight to the strip light like this, or you can use a little cable whip for a series of lights like this. Oh my gosh, everything is all over my bench. So I could strip this wire back right here that's on my pixels, solder that right onto there, and now I've got my pixels running up to 100 meters away from my controller. That's huge. That's important. That's the only way that SPI and TTL pixel lighting has become what it is because people have figured out how to extend this unbalanced protocol of lighting controls out to 330 feet. So these systems right here are the way to go. And again, I said, Digidot's not the only one. However, I would be more than happy to just pitch Digidot all day long. They tend to be a little more expensive, but their capabilities are more than advanced. And the technology systems that they have are absolutely spectacular. So if you don't like this as a PCB, right? Oh, this is really frustrating. I don't like this. Well, we could solder all of this up in the field. You could solder all this up ahead of time, put it on your pixel strips, and then wrap a piece of heat shrink around it. And before you obviously put it outside, you throw some Corrosion X on it too. And this sucker's going to last a long time. Figure out how to mount this into a junction box. There's all kinds of ways that you can get this in, and now you're within that 10, 12, 16 feet of your SPI pixels, and you've run that out. Another big important piece of this is to power inject. So, soldering on this back side here for the power injection and running the SPIs off the other side of the board over here, that's how you would wire this up. There are systems now too from a couple other different manufacturers that are now offering this in a module, and a module that can be rack mounted or DIN railed mounted up. This module can fit inside of a junction box, put a lid on the top of it. Yeah. Okay, I don't know exactly where we were, but okay, we'll just cut in. So cutting in over here, these guys, these are our little SPI receiver side units. And in fact, you can actually use these on both sides, but they are a transceiver, so they can be transmitter and a receiver of the SPI protocol. On side of this, you have this little RJ45 to receive that from the main controller. So this is the main controller sending out the RJ45 connections. This guy's receiving it. One side of the bottom side is where you do the power injection. So you do your power and your ground on one side, solder that up. On the other side, you solder in a whip tail, whether you're coming off of one of these kinds of little SPI types of pixels like these guys, these little Christmas pixels, whether you're coming off of like a sine module like this guy, you just solder those up onto the top side of here with the right pin out, and you've now effectively extended your SPI I would say the non-polarized version of serial digital protocols. You've sent that out 330 feet, 100 meters, which is pretty great. So all that to be said, pixels have limitations. Pixels are amazing. Pixels, frankly, are the future of everything. They are being integrated into everything from cosplay to automotive to digital signage systems to digital signage backlight systems to displays. We're seeing pixels and motion pixels and moving pixels pretty much anywhere and everywhere. And I predict they're just going to continue to go on and on and on. So getting caught up with this advanced technology of digital lighting systems is an important piece. I do a training course on, it's basically a 2-day course introducing to the SPI protocols. We talk about the different types of protocols, some of their backgrounds, why they exist. We talk about DMX conversion from DMX itself coming out of a standard DMX controller, be it a theatrical or otherwise, converting it to the SPI, converting it to the ArtNet, SACN types of protocols that allow that control protocol to be sent multiple universes of 512 across an entire network. And then we talk about converting it to SPIs, TTLs, DMX, other types of things, and then sending those SPI protocols from controllers like this guy long distances out to the destination where the actual lights finally are displayed. So that is a 1 or 2 day course. First day is just talking about, introduction to the SPI, kind of getting a broad overview as to how DMX, other types of controls run SPI protocols, how to program them in from a basic standpoint, and then how to do the distribution, what types of controllers to look for, how to use them. I'm just using these because they work. I've used them for a number of years in my shop. There's other technologies that are out there that are as good. Maybe sometimes they're cheaper, and maybe they require a little bit more details. But these guys, I use them because they're rock solid and robust. And there's some new stuff coming out, so I'm not 100% committed to this, but I do love it. And frankly, if Digidot was to say, hey, Nate, I'll sponsor you, I'm totally for it. Same with Corrosion X. Again, if you guys want to sponsor me, I'm all for being sponsored. You can let me know because I swear by this stuff. So even if you guys never sponsor me, I swear by it. I'm going to tell everybody about Corrosion X and Digidot for the rest of my life as you guys continue to build good products. So yeah, I mean, so if you guys want some more information about that, I do a training course. First day is introduction, like I said. Second day is actually hands-on, touching it. You guys get to actually get involved, wire some stuff up, put some things together, and build some lighting systems with me. So that hopefully would be introduction and informative. So if you like these videos, you like what I'm doing, and getting a little bit of information out of this, hopefully learning a little bit too, let me know. Like and subscribe. Let me know in the comments what you think. If you guys let me know, I'm going to be looking at my comments. If you guys have need for some of this support and help, and you guys looking for somebody to give you a hand, give you some pointers, that kind of stuff, I'm definitely available for being hired to help you out with that. So thanks again from an old guy to you guys. See you guys on the next one. Thanks so much.